Fungecraft is about halfway done, and you guys seem to really like the last video, so let's finish it. So we have dot, which is pop the top of the stack and output it as an integer. So for example, if there's a 43 on the stack, it will just output a 43. And the comma will pop the top off the stack and output it as an ASCII character. But what does ASCII mean? Well, ASCII is basically a way of encoding certain characters with numbers. So if we had 43 on the stack and we had a comma, it would look on this chart for 43 and then it would output a plus, because that is glyph that is related to 43. And the block we're going to use for this is the block of redstone. Let's just change up the program here a little bit. Put a block of redstone there. We have a 2 on the stack, so hopefully it should output a 2. It has a 2 in it. You may have noticed it didn't actually say anything, so we need to code in a little thing that will, at the end of the program, say out whatever is in the out storage. So just here in the bedrock check, instead of killing it, we're just going to run the function end. In the end function, we're going to kill the armor stand, and what we're going to do here is I'm just going to paste this in. This will basically get everything from the out part of the Fungecraft main storage, and interpret true means it will basically stick it all together instead of like that. It will just do something like that. It says just 2, and then if we, for example, put another redstone block here, another chest there, put a 3 in there, 2, 3, 2, that's because the 2 was there from before. So we really need to make it reset at the beginning of every iteration. So hopefully that should all be coded in. If we run the function start, then it should summon the block, and then it says 32, and it should always reset. So if we run that a couple more times, it always resets to 32 and it doesn't have the leftovers from the previous run. So now we move on to ASCII. This should again be fairly simple. I think I know how to do it. Okay, so what we're going to do is we basically modify a data storage called Fungecraft constants, and we modify the ASCII property, and we're just going to set it to this. This is just some code that I wrote in another language that outputs all the ASCII characters up to this. This is like the main ones, but it doesn't seem to like the \u, so I'll just get rid of those quickly. Okay, so it doesn't like the \b, \t, or any of these other ones either, it seems like. And also \n. That is going to be a problem, because with /telraw, if you type a \n in your message, you can have it on 2 separate lines. But if we can't have it on a storage, then I'm not exactly sure how we're going to do that. We'll figure that out when the time comes. But anyway, let's write the output ASCII function, and first we're going to have to start off with writing something that will find something in that ASCII array based on a certain value. I also want to say, whilst I'm coding this, that bfunge is actually Turing complete. Now, if you don't know what that means, I won't go into too much detail now, but basically it means it can do the same as any other normal programming language like C or Python. This means that if we can accurately recreate it with Minecraft datapacks, then Minecraft datapacks are themselves Turing complete. I'm going to use an oak sign for it. Maybe we should have a warp sign be the instead of a redstone block. Okay, so now if we put in a 9 and then another 9 to multiply them, we should get 81. Then we put an oak sign here, which will output that as an ASCII character, which should be the letter capital Q. 9. Okay, that didn't really work as anticipated. Okay, so now hopefully it says 81. Okay, so I've changed this around a little bit, and so hopefully this will work now. Nope, it still said 81. Why? Oh, okay, it's just because I had the wrong function name from before. It still says 81. P, okay, that's 1 wrong, so we just need to change something quickly. Q, okay, then we can just remove all of this debug stuff, and now it just says Q. Oh, that took a long time. So we've got our outputs working. Let's work on inputs. What is the best way to get a user input? You can't get them to type something in chat because you can't actually read that with commands, but you can give them a book and quill. You could give them a sign that they're supposed to write down. You can get them to write something in the command block, but probably the best thing to do is with the book and quill. So we give the player the writable book, and we just need to figure out how to detect when they have used the book. Okay, so it looks like even after we turn it into a written book, it still has the Fungecraft input 1b. So then what we can do is we can constantly try to clear the written books with Fungecraft input 1b. But the problem is you're only allowed to input one character at a time. So we also need to figure out how we're going to extract that single character. The block for this is going to be a lectern. Okay, so I got a book and quill. The running thing didn't seem to work because it still ended, but if we just type, for example, A, okay, I think I fixed the issue. He's waiting there until I write something, so if I write my A, okay then. Okay, hopefully that fixes it once and for all. Yep, so it's checking. It cleared it. It's because it clears it before it can set the things off, so we need to do that afterwards. Get the book, put an A in it, title it A. It didn't seem to append it, but it did end. I'm confused. Why is it not tailoring like from that A? Okay, well I'm sure we'll figure it out in a little bit. Okay, so I just took a quick break and I realized that we don't actually need to add it to the output. What we need to do is get the ASCII value of the character that they type and then push that onto the stack. And I thought long and hard about how we're going to actually do this, and I don't really see any good way to do it. Because the syntax is something like that, it's kind of difficult to extract this character, and even if we could, there's not really any way to check if two storages are equal. So one way you might think of getting character and trying to find the ASCII value of it would be to go into our ASCII array and basically just loop through it and check if the current character is equal to the current value in the array. But the problem is we can't actually check if two data storages are equivalent. Minecraft really needs to add some more functionality to datapacks because it's really hard to do anything like this. Working with strings is just a pain. So I guess what we're going to have to do, the only way I could think of, is we brute force it. So we, for example, we do execute if data storage Fungecraft main current this data modify storage Fungecraft main arg0, and we're gonna set the value to be 93, or I think it's 93, whatever the ASCII value for lowercase a is. And then we would have to copy paste this and then just do the same but with b and 94, which is gonna be messy, but I think it might be the only way to do it. I guess I'll just spend ages on this then. Okay, I've actually realized that this is going to take ages, so I'm actually going to automate this, and I'm going to write a piece of code which generates this file for me. Okay, so I've just realized that actually, if there's only one character, it's literally just the character. This will actually make our code a little bit more efficient. We'll set it to capital A, then we run the function. Now, let's get the storage, and args has 65, which is the ASCII value of A. That is working well. So then after we get the ASCII value, then we can just run the function push, and then that should push it to the stack. If we data get the storage to the stack, it should have 65 on it. Okay then, so now in check for input, after that we just need to run the function ASCII to num, and here instead of appending it we're going to set it, and instead of setting the out we're going to set the current. What we can do, we have the lectern to take the user input, and then the sign to output it. We got our book and quill. Let's type an A, sign it, sign and close, and it didn't work. It has a bunch of 9s on it. Has those 2 9s. I'm confused. It has even more 9s on it. Why does this... Oh, so hang on. I think when it's a written book, it has the text, but when it's a book and quill, it just has the plain character. What we could do is you have it so that you type, say, something in the first page, and then on the second page, you type go or done or something. Or we just re-add back in the check for the JSON. I think let's do it this way. Okay, so now if I do this again, let's just destroy these. Okay, so now if I run it again, click done, nothing happens. Go on to the next page, type done, it clears it. And now if we get the storage, and the stack has 97 on it. Why does it have all of these 9s? That's the question. I don't know. But anyway, if we put a sign here now and run that again, H, done. It outputted an H. But why has it got all the 9s? If we break those, it has 0s on it. Why is it trying to push stuff onto the stack then? It says an A, and if I get the storage, it doesn't have tons of 0s on the stack. So our input is working as an ASCII character, but we also need to be able to input as a number. This could prove to be tricky because whilst there are a finite number of different characters that you can... I mean, obviously you can type with like strange Unicode character like that with an accent, but for now we're just going to ignore those. But with a number, you know, you could type a 1 or a 2 or a 3, which would be really easy. But what if you wanted to type 10,094? We can't write 10,094 commands because what if you want to type 1 million? And 1 million, you know, that's just going to get really laggy. So here's what I'm thinking. First of all, you can only type 1 digit per page. So if you want to type in 12, you type 1 and then 2. Then at the end, you type done. And what that will do is it will parse them page by page. And so it will say, okay, 1. That's a 1, that's a 2, and it only needs to deal with single characters at a time. Then we can do some mathematical operations to, you know, multiply this by 10, then add it to the 2, and then we'll get 12, and that should be alright. And while I'm coding this, I just want to say that these videos have taken a ton of effort to make. It's really tricky to try to figure out how to create these complex concepts using Minecraft datapacks. Plus there's the editing of multiple hours of footage. So if you got to this far in the video and you've watched the previous one, it would mean a lot to me if you would subscribe because it helps me out, it takes literally no effort, and it will help you to see more videos like this. Okay, so this turned out to be a lot more complicated than I originally anticipated, but I finally figured out something. I have no idea if it's gonna work or not, so probably the best thing to do would be to test it one by one. Let's test parse digit first. It didn't seem to get the thing. I set current to be 1. That worked. So why isn't it working inside the actual function? Oh, because it sets the value at the beginning. So what we're going to do is we'll actually do scoreboard players set .a fungecraft -1. Hang on, we don't even need to have this line because, hang on, I just had a thought. What happens if we try to do execute store results score .a fungecraft, and we're going to do data get storage fungecraft main current, but it's actually a string. Let's just set it on the sidebar. Oh, it actually works. Well, let's just check that works. If we have that be 10, then we run that again, 2. Oh, so you can get the length of strings by doing that. So if we had, for example, like this, then it has 28 because that has 28 characters. Okay, so you can't do it quite like that. I mean, we could have a unary system where you just write like that, but that's kind of annoying. But anyway, the parse digit function should now work, and now it has a 1. Perfect. Okay, so now the slightly more complicated parse number, but first I actually had to write a power function. I mean, come on Mojang, can't you at least have some kind of built-in powers? So let's see if this works. So let's say we're calculating 2 to the power of 3, then we'll run the function, and we got 8. So it looks like our power function is working. Let's just check that. So let's say if we have 5 to the power of 4, that should be 625. 625. Okay, so our power function is working. The question is, am I smart enough to create a full parse number function, or have I messed something up? and that has given us 60. So that is obviously not correct. The question is, where did we go wrong? Okay, so I'm just executing this line by line and making sure that everything is working properly. I think I know one thing went wrong. First of all, it can't be 1, 2, 3, it has to be that in quotes. Now for the moment of truth. How does it handle powers of 0? Ah, that's a problem. It ended up with 10. Only run the function loop if we have a score of 1 or more. So I'll modify the storage again, then I'll run the function. It's still got 60, so something's still wrong. I also realised that the numbers are actually backwards because currently we have 1 as the least significant digit, so we're going to have to perform a reverse on this, but we'll do that afterwards. Let's try to run the whole function now, because I'm pretty confident that it will work. Nope, we still got 60. What is wrong? Let's run through all the commands again. Okay, so I've just run through every single command, and the output here is exactly what we want. Well, it's backwards, but that's fine because that's just a flaw in the code. But why does it not work when I run the function? Oh, it's just because we need to reload, right? There we go. Oh my god. Well, that was a big waste of time. Now we just need to reverse the numbers and then our parse number function will finally be complete. 1, 2, 3. Okay, finally. Our number input block is going to be an observer. Let's first just see if this lectern still works because I did change the mechanics of that a little bit. It does still work if I replace this with an observer, like 1, 2, 3, done, 0. It did 1, 2, 3, 4 for some reason, but why did it output a 0? So yeah, it seems to add a 4 into the end, whatever I do. Oh, because it's treating the done as 4 because it's 4 characters. So now finally, after so much effort, we can parse numbers. So now we have 3 more things left. And here's where I'm not really sure how to proceed, because in Bufunge, obviously Bufunge is made out of characters, single letters or symbols. So, for example, toggle string mode, interpret what you have next as a string, so push the ASCII value of each character until it gets to the next quote. You can just do that because it's actual characters. In Minecraft, however, it's not that simple. How do you translate a block into a character? I'll have a think about it and I'll continue recording once I have the answer. Okay, so I slept on the idea and this is what I've come up with. Every block has its unique ID, which is just a number between 0 and 126. Why 126, you ask? Well, because there's 126 ASCII characters. To pay some tribute to Bufunge, I am going to use the same ASCII values for the blocks in Minecraft that correspond to the same operations in Bufunge. So for example, for the honeycomb block, that is equivalent to the Bufunge character asterisk, so it will be the same ID as the ASCII value for an asterisk. First I'll just code in the basic mechanism and then we can start building up a table for the actual IDs. This data pack is not multiplayer compatible. It would technically work on a server, but the inputs are given to the closest player to the armor stand at the time, so it might get kind of weird with different people standing around the place. It also definitely doesn't work with multiple instances of the program running at the same time because some of the different scores and state storages will mess with each other. Okay, so I've coded in string mode. What string mode means is that it just pushes the character's ASCII value until you get to the next quote, or in this case, string. So what I've done just for now is that once string mode's on, if the block is air, then it will push a 32 to the stack because that is the equivalent to the ASCII code for a space, which is the same as air in Minecraft. The function, that didn't turn. Okay, so if we run the function again. Okay, so I need to set it to 0 when it's already on instead of 1. It's just one number, so it finished. Put some signs here. This will output it as the numbers because we want to check to make sure that we got the right numbers. 0, 0, 0. Okay, that didn't work. So now we got the 32, but why wasn't it doing it before? Oh. It seems to only be checking it on these 2 things. Yeah, so we have another kind of similar problem. Basically what's happening is that first of all, it runs the check block function. It says, okay, this is string, so now we're in string mode. Then it performs string mode, and here in string mode it says, okay, this is string, now we're out of string mode. Then it runs the function check block again. It says, okay, this is string, put on string mode again. And then, as you see here, it just continues for infinity. Okay, managed to fix it. I just added an intermediary score that gets changed to indicate when string mode is needed to be changed. So string mode is working. Now we need to just change the block to string method to incorporate a bunch more blocks. This is going to take a while. It is finally done. I've left these two out because that is G and P, which we're going to assign later. So as I said, for example, an observer is equivalent to the ampersand character in Bufunge, and sure enough 38 is the ASCII code for an ampersand. For the blocks that didn't have any functions, I mostly went with some kind of logical progression. For example, the colors of the rainbow in different blocks. Or down here I had the ores in kind of progression of value, so for example it starts with stone, then coal, copper, iron, etc. I'm not going to go through all of them now because there's literally 126 of them. But when I release the data pack, I'll make a chart with all of these on so you can easily look them up. So now back in Minecraft, let's see if we can finally make a Hello World program. Now if you're not that familiar with programming, basically a Hello World program is just one of the programs that you make when you're learning a new language to assess your kind of skill and make sure that you know how to use the language. A Hello World program is very simple, pretty much the most simple one you can do, and it just prints the words hello world. So to do that, we'll just need to do a string, and then we can write hello world in here. Now also, just because of the way that the Bufunge stack works, we actually need to write it backwards, so this bamboo is an exclamation mark, because it's the end, and then this will continue going this way. Okay, so that is the string hello world backwards. Looks quite pretty with the different colours. Then you basically create a loop, which loops through the characters and outputs them. Like that, and then hopefully now if we run the program, it says hello world without a space. That's because I've been dumb and I forgot to put the space in there. And now it finally says hello world. Man, it's taken a long time to get to this point. We're so nearly on the home stretch. The only last things we need to do is G and P. These are data storage operations. So G is a get call. So it retrieves data in storage. It pops two values, y then x, then pushes the ASCII value of the character at that position in the program. So what that would be like in Minecraft is, for example, all of the coordinates will be relative to the program. We're going to need to code in some limits for the program because it's only supposed to be 80 by 25 blocks. This will be 0, 0, and then maybe over here is what, like 5, 4, and so we would have a 5 and a 4 on the stack, and then it'll pop those and say, okay, what is the ASCII value of blue terracotta? It's 111, so we'd push 111 to the stack. A put call is essentially the opposite. It pops y, x, then v, and so for example, we have 5, 4, and 111, that would basically pop those, find 5, 4 in the program, which is here, and pushes the block with the ASCII value of 111, so that would be blue terracotta. Also, it's not really ASCII because ASCII is characters. This is the MSBE, the Minecraft Standard Block Encoding. So first we're going to need to make a system to get the relative coordinates of that position in the program. Okay, so basically when the program starts, it gets the coordinates of the starting armor stand, so that's basically start X and start Z. That is the coordinates in the Minecraft world that correspond to the start of the program. In Bufunge, you don't have to specify a certain character for where the program starts. It just intrinsically starts in the top left corner. So what we're going to do is this is going to be kind of like -1, 0, or in this case more like 0, 1, because it actually starts going towards -Z. So this is then 0, 0 in the program, which is the first actual instruction that it will run. Okay, so first of all let's test to see if our logic has worked with the teleporting back to the beginning. The way we're going to do this is we'll just have a magenta glazed terracotta going this way, and then hopefully it should wrap around, it won't get anything, and then it'll wrap around to here while it'll hit bedrock. Nope. Okay, it didn't work. Okay, I was just really dumb. I stored the data onto the entity's position as a float, but it's actually supposed to be a double. Okay, let's see if this works now. No. Okay, so I finally got it to work. Took quite a lot of jiggling around with the code, and I actually ended up making it start going south, because then it goes positive Z, and that just makes it so much easier. So basically, it's an 80 by 25 plane. So we could just outline it like this. This, I'm pretty sure, is the full extent of the Bufunge program that we have access to. And I made it so that it starts on the stone, you run the function on the stone, but it actually starts its execution here, which means that you have the full 80 by 25, provided we get rid of this stuff. So hopefully now if we do something like this, it should output 0 and it shouldn't end there. Yep, there you go. You saw it outputted the 0 because of the sign. So this means it is correctly teleporting before it hits the end. Now let's check in with our get call. So we push 2 zeros to the stack and 0, 0 is here. So hopefully now if we place a note block, nope, still had a 0. 58, okay, that time it worked. I don't know why it wasn't working before, why it outputted the 0. Okay, so now we finally get to add the very last command, which is putting a piece of data somewhere in the program. So now if we put, say, 2, so that is the value, then the y coordinate is going to be 3, and then the x coordinate will be 0. So it should put grey wool here, except first we need to place a sticky piston to put it there. Oh yeah, because 0 is black, 1 is grey, and 2 is brown. Our Fungecraft language, aka Bufunge, is working 100%, and we have successfully proved that Minecraft datapacks are Turing complete and can perform all the same calculations as any other programming language. Hello there, Gears from the future here, and after I'd finished recording that, I realised that there were still several different things that I had left unfinished. For example, I still hadn't added a way to use new line characters in your code. But now that's implemented, so now if we press this button here, basically you can have new lines, tab characters. That's the only kind of formatting that I had so far, but I might add some more formatting things in the future. Secondly, there were a few bugs with some of the different things, like I don't think the lectern was working properly, the observer, but those are all fixed now. Now, to make it a little bit easier to start, instead of having to do like /function and then scrolling down here to start, what you can do is you can type /trigger and then you do play, and then that will do the same thing as if you ran the function. You also may have noticed there is the help. It's basically giving a little bit of information, and then it will give a link to the documentation where you can read all the rest. But yeah, that means we successfully proved that Minecraft datapacks are Turing complete. We made Bufunge in Minecraft. I'd highly recommend checking out Bufunge and other SLangs because there are some really interesting things that people have made. You can also download this datapack in the description and have a play around. I'd like to see what you make. And if you want to see me make diamonds and coal completely renewable in Minecraft, check out this video here.